We're going to find the maximum and minimum of this function, which is a quadratic equation. And we're going to state the domain and range of the function. Notice this function is in standard form. Standard form looks like this. It's f of x equals a times x squared plus bx plus c, where a cannot be equal to 0. And what we want to do is, knowing the form makes a difference. So to find the maximum and minimum of the function, and we know that it's going to be a parabola, that means that we're going to have to find the vertex. So the first step, or we'll call it A, we want to find the vertex. In so doing, because it's standard form, we're going to have to do a little bit more work than if it was in vertex form. So we're going to start out, and we know that the x value of the vertex, when it's in standard form, is x equals negative b divided by 2a. So the first thing we want to do with this function is we want to be able to name a, b, and c to start out. And this is good training for us to get in the habit of doing this, so that when we do the quadratic function, it's really easy for us to name a, b, and c. So if I start out and name a is the number in front of the x squared term, but in this case I don't have one. So it's understood to be 1, but notice the sign. So a is negative 1. And then b is the number in front of the x term. In this case it's negative 6. And then finally c is the constant term. We're really not going to need it in this problem, but just for the sake of getting in the habit of doing it, we're going to go ahead and name it. All right, so now I take these values, and I'm going to substitute those in here to find my x value of my vertex. So my b is negative 6, so I'm going to have a negative 6 divided by 2 times a negative 1. And then it's just a matter of simplifying. Notice the negative here becomes positive, makes it a 6. Over 2 times negative 1 is a negative 2. And when I simplify that out, 6 divided by negative 2 is a negative 3. So I know that the x value of my vertex is going to be at negative 3. Now, to find the y value, I have to go back up here to my original function and evaluate it at x equals negative 3. So I'm going to find f of negative 3. So everywhere in the function that I have an x, I'm going to substitute in a negative 3 and then use the order of operations to figure out what that comes out to be. So it's going to be a negative 3 squared minus 6 times a negative 3 plus 3. And then we just simplify. So that's going to be a negative 3 squared is going to be a positive 9. But keep in mind I have this negative in front, so it's going to make it a negative 9. And then I have a negative 6 times a negative 3. A negative times a negative is a positive 18 plus 3. All right, so now let's simplify that. That's going to give me a negative 9 plus 18 gives me 9 plus 3, which is 12. So that tells me that my vertex of this parabola is going to be at, remember my x value was negative 3, it's going to be negative 3. My y value that matches with that is 12. So that means I'm going to either have a maximum or minimum at that point. Now, to determine whether it's a maximum or minimum or not, I need to kind of look at the graph a little bit. So I'm just going to kind of sketch the graph out. And if you recall, the number in front, or my a, was a negative 1. So that tells me that the parabola is going to open down like this if I graph it. That means the vertex is going to be here. So if you're looking at that, notice that is the high point on this parabola. So therefore this vertex is going to be a maximum value. So we have a maximum here, and it's because the parabola opens down. And that is because a was equal to a negative number, or a negative 1. Now let's actually go look at the graph of it for a second. So I have my function back. I know that the vertex was at negative 312. So if I do negative 312, that's where I'm going to start. So negative 3, so 1, 2, 3, and then up 12. My graph doesn't hardly go that far, so we'll just kind of superimpose it there. And because of this being a negative out front, I know that's going to open down, something similar to this when I graph it. Now I could do a table of values. Since I know that my x is going to be a -3, then I could pick values and do a table, something like this. I'm not actually going to go through all that, but just to kind of show you, I would pick two values to the left of -3, like -4 and -5, and then I'd pick two values to the right of -3, like maybe -2 and -1. I'd fill out the table, so I'd find f of -3, which we've already found, f of -4, and so on to get my values to graph it if I want to be real accurate, but I don't really need that because all I need to do is talk about the domain and range. Well, once again, with a parabola, the domain is always -infinity to +infinity. The range is the part that could be a little tricky sometimes. The range, remember, is the y values. So what I want to do is look at the y values, and this top value on the y-axis is going to be at 12. So that tells me that's the maximum value. And then if you notice, the parabola continues to go down on both sides, and it goes down infinitely. So since I can name this point, I put a bracket, and it's at 12, and it goes all the way down infinitely. So that's a negative direction, so we call that -infinity. So the range in this case, the y values, are +12 to -infinity.